Section 4.8b is about writing equations from patterns. A couple of sentences we want to look at. Sometimes a pattern can be a general rule if the relationship between the domain and the range is linear. If it creates a line, then that relationship can be described as a linear equation. Sometimes we call that a linear function. That's what we're going to look at. We're going to look at patterns that create lines, and they're going to create linear equations or linear functions. Here we're going to learn to write an equation based on some data that we're given. The data here is the amount of gas Rogelio's car uses to depend on how many miles he drives. So this is a table. A couple things to note about this table is the first line represents my domain. So these values are my domain values. Typically the domain values are represented by the letter X. Now in our example here we're talking about gasoline, so we're going to use a G. But understand that these are the domain values and they represent the same thing as X values. Likewise, the miles driven, those are my range values and they represent the Y's typically, but we're going to use the letter M because they stand for miles. So look at the table. We're going to graph the data and then try to find a conclusion. So if we graph the data, we're going to treat the gallons as X's and the miles as Y's, and we're going to put those dots on this graph here. Now because of the space here, I have 5 points, so I'm going to skip every other one because it'll make my graph look nice. So I'm going to label these 1, 2, 3, 4, and 5 for the gallons. And then for the miles, 140 is my biggest, so I'm going to make each one of these worth 20. And now I'm going to graph the 5 points. So there you have my 5 points. They look like they're in a straight line. It looks like a linear relationship. So what conclusion can we make? They form a linear relationship. Now we have to write an equation that describes that relationship. So let's go back up here and look at our table because it might be easier to see that. Every time my gallon goes up by 1, what happens to the miles? Because these are always plus 1. Well, what happens? The miles goes from 28 to 56. That's a 28 gallon increase. And another 28 gallon increase, and another 28 gallon increase. So it appears that every time the gallons go up by 1, the miles increase by 28. Now we've got to figure out how to write that as an equation. So for every Y value that goes up by 28, the X value goes up by 1. So I could say it this way. I could say every Y value is 28 X's, because every single time I put a number in for X, like a 1 or a 2 or a 3, I multiply it by 28 and that gives me my Y value. But I'm not using Y and X, I'm using G and M. So I could also say that the miles equals 28 times the gallon. But one more thing I want to do is I want to write this as a function. And remember, a function, we'll call it f, uses the domain letter, f of g equals 28 G. So this is how we're going to write our equation, our relationship. That means every time I put a number in for the gallon, I multiply it by 28, and that will give me the value for the miles driven, or my range value. This is how you create a linear equation based on a set of data, and how you write the equation to show the relationship. Here's more practice writing an equation from the data. We have hours that we're driving and how many miles we're going to drive in those hours. We'll call the hours the H value. They also represent the X or the domain, and the miles we'll call little m. Now I'm going to just do this right off the bat. If you notice, each one of these is a plus 1, and then the difference between each one of these is a plus 50. We're definitely going to need that information a little bit later, so I wanted to do it right now. Now we're going to graph the data. I have 4, so I'm going to jump by 1s here. Here I'll jump by 50 for my range, and now I'm going to graph the 4 points. So there's my data graphed, definitely linear. Now I want to write an equation that describes it. Well, for every 1 going up of the hours, I get 50 of the miles. If you thought about this as X and Y's, we could say that for every Y, it's 50 times the number of hours. That would be my equation looking like with X and Y's. But with M and H, I would say that the miles is 50 times every hour. So H. Last thing to do is write it in function notation. Function notation, we'll call that F. Now what value goes in here? The domain, which is my H, and that equals 50H. So I plug in the number of hours, multiply it by 50, and that gives me the number of miles that I've driven. That is my linear relationship. Here we're given a graph and we're asked to write the equation in function notation. Now the way to do that is we have to look at points, but first we're going to take these points and put them into a table because I find it a lot easier to graph values in a table than I do just on the graph themselves. We'll call the top one's x, the bottom one's y. So here our first point looks like it's at 1, 1, 5. And then we'll just finish by doing that to all of them. So listing all 5 of the points that you see on the line here in a table, we can then look for any patterns that we see. It looks like there's a +1 pattern for all my x's and a +2 pattern for all of the y's. So we've got to figure out what that looks like as an equation. So if we do this the way we've done the last couple, for every y value that we have, it would seem we would need 2 x's to match that. Now, one thing you should do is you should go back to the points to make sure that that works. If I plug a 1 in for the x, do I get a 5 for the y? 1 times 2 equals 2, not 5. So it seems that these don't actually work. So what we're going to have to do is we're going to have to do some sort of an adjustment. Well, when we do plug a 1 in, let's take a look what that looks like. When we plug a 1 in for the x, we end up getting a 2. Well, what can we do to a 2 to get it to a 5? The answer is we can add 3. So I want to check something. I want to look at what that adjustment would do if I plugged in any of my other points. Like let's say 4. Let's plug in a 4 for my x value. And 2 times 4 is 8. What if I adjust it by adding a 3? I'm going to get an 11. And it turns out that if you can plug in any one of these y values, let's try the 5. 5 times 2 is a 10. If I add 3 to that, I adjust it by 3. So my actual equation that I'm going to use is not just 2x, it's going to be 2x plus 3. First you find what the relationship looks like based on the differences, and then you have to plug the points back in and maybe find an adjustment that you have to make. Here we have another example of a linear equation or a linear relationship that we have to write as an equation. We'll start by taking all 5 points and writing them in a table. Here we actually have 6 points, and so we write them out as a table, and now we check on the difference between each one. Looks like the pattern on the top is a +1 between each of the x values. And the pattern on the bottom appears to be a -1 between each of the y values. So that would suggest that y equals a -1 times x should be my pattern, because for every 1y, there's a -1 for the x value. Now the trick is to see if that actually works by plugging in a couple of points. So -1, we'll plug -2 in. And that's going to give me a +2, but I want it to be a +1. So what adjustment can I make? I can subtract 1 from that. Let's see if that works in other places. -1, this time we'll plug the 0 in. It's going to give me a 0, but I want a -1. So if I subtract 1. So it appears as if the adjustment is -1. So my equation then would be y equals -1x minus 1. I'm going to write that in function notation. Or finally, the final way I can write it is just -x minus 1.